Welcome back to the second part of Trig P.6 or Pre-Calc 1.5 notes. The topic we're going to start off with in this section of the notes is a topic that tends to be a little bit difficult for students to catch on to. It's the concept of whether a graph is even or odd. And if you think about it, it seems like it should be a pretty easy topic because most of the time we can look at our equation and we can say, oh, if it has an even exponent, it's going to be even. If it has an odd exponent, it's going to be odd. And that will work most of the time, but it doesn't work all the time. So we have to have an algebra test that goes with it just to verify that if it is a degree 2 polynomial, it should be even. If it's degree 3, it should be odd. So here's the test that we're going to do. We're going to replace x with negative x. And depending on the result that we get, will tell us whether our equation is even or odd. If we replace x with negative x and we get the original equation, then we know that it's going to be even. If on the other hand we make the same substitution, x with negative x, but we end up getting negative of the original equation, then our answer is going to be odd. So let's take a look at this example here. If I replace x with negative x, that's going to make my equation be a negative x squared minus 2. When I square a negative x, it becomes positive. And notice that that is my original equation. So when I made the substitution x with negative x, I got the original equation. That's exactly the same as what I started with. So therefore, this means that this equation is going to be an even equation. And when we say even, it means that it's going to be symmetrical along the y-axis. If you were to take the time to graph it, you would see that this graph would be symmetrical at the y-axis. Now, on the other hand, if I look at this degree 3 polynomial, I'm going to make the same replacement here. I'm going to take x out and put a negative x in its place. And notice when I'm doing that, I'm deliberately putting them in parentheses because I want to make sure that the negative gets cubed here. So when I cube the negative, it stays negative. This time it would become a plus x. So this is not my original equation, but notice that my original equation has opposite signs. That's positive, and that is negative. So if I factor out a negative 1, that would make this negative x cubed positive, and this positive x negative. And remember that this right here, that's my original. That matches x cubed minus x. So I really have a negative 1 and then the original equation. And that's what I was looking to find when I have a odd function. I want negative of the original. So the only way you can get negative original is to do this. Make the substitution of a negative x and then factor a negative 1 out of all of the terms involved in the polynomial. In this case, there's only 2. And when I factor out the negative 1, I end up with a negative of the original. So then I can make the conclusion that this is odd. What a lot of students will do is they'll just look at the polynomial up here and they'll say, oh, because that's degree 3, it must be odd. Or because it's degree 2, it must be even. And most of the time you'd be correct, but I want you to show me the algebra check that's associated with that. So you need to do the algebra behind it and not just write down odd or even. And again, the replacement is the same for both of these. You're going to replace x with negative x both times. It's just whether you get the original or the negative original will depend on whether or not your answers are even or odd. The next concept we're going to talk about is something that you're going to use quite a bit when you get to calculus, and it's called the average rate of change formula. So here's the formula. And what the average rate of change will help us do, it'll help us take a graph that is nonlinear, for example, this parabola, and it will allow you to be able to find the slope of that graph. And we know that if we had a linear equation, we could find the slope just by doing y sub 1 minus y sub 2 over x sub 1 minus x sub 2. But because this isn't a linear equation, what we can try to do is draw a line through a piece of it, and that's called the secant line. And using this formula, that's going to help us find then the approximate slope of this parabola. So if it's asking me to find the average rate of change of this parabola, which is graphed here, let's look at where x is 5, which is right about here, and where x is 1 is right about here. And so what I'm really trying to do is come up with what is the slope between those 2 points. And this dashed line that I'm drawing, that's really the secant line. So I can find an approximation of the slope by finding the slope of that line. And the way I can find the slope of that line is to plug it into this equation. So the first thing I have to do is find f of x sub 2. So I'm going to find f of 5, subtract from that f of 1, and divide that by x sub 2, which is 5, minus x sub 1, 4. So to find f of 5, you have to plug a 5 into here. So f of 5 is going to be 5 squared minus 2 times 5 plus 8. 25 minus 10 plus 8 is going to give me 23. So I'm going to have 23 minus, find f of 1, 1 squared minus 2 times 1 plus 8 is going to give me 1 minus 2 plus 8. And that's going to end up giving me 7. So I'll put a 7 in here for f of f1. And then 5 minus 1 is 4. So I get 16 over 4, so I can say that the approximate slope of this parabola is 4. And this is going to be a concept that you're going to use quite a bit when you get into calculus.